All right, good morning, algebra. Well, it's morning for me. Here we go with notes number 9. There are 3 different possibilities for solutions to a system of equations, and we've talked about this before. Sometimes we can have the lines with different slopes, and here's one of those considerations. They have different slopes and different y-intercepts. If you have 2 lines with different slopes and different y-intercepts, they're going to cross at one point and have one solution. Sometimes you have lines that have the same slopes but different intercepts. Those lines are never going to meet. We say those lines are parallel, so therefore there's no solution. Sometimes you have lines that have the same slope and the same intercept. Those lines are actually the same line, and they have a special word for what they are. They have infinite solutions, and we call those lines coincident. Like, what a coincidence, we're the same line. They are coincident, C-O-I-N-C-I-D-E-N-T. So when you look at 2 equations, depending on whether they have different slopes and intercepts, same slopes, same intercepts, or same slopes but different intercepts, depending on what they have, we can go ahead and look at their solution. Okay, so we can solve this system by graphing. Y is equal to negative 2x plus 5. 1, 2, 3, 4, 5. And slope of negative 2. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And solve the second equation the same exact way by subtracting 2x from each side. Y is equal to negative 2x plus 1. Check it out. We have the same slopes but different intercepts. So I know exactly what's going to happen here. I'm going to go to my intercept of 1, and I'm going to go down 2 over 1, down 2 over 1. And then when I connect those lines are in fact parallel, and they will never meet. So we can say lines are parallel. I always remember how to spell parallel because it has a set of parallel lines inside the word. Lines are parallel, therefore there's going to be no solution because those lines will never meet. So we don't solve our systems by graphing normally, so we need to know what this looks like when we solve the system with substitution. So if I have 2x plus y is equal to 5 as my first equation, and 2x plus y is equal to 1 as my second equation, I'm going to solve for y, and I'm going to say that y is equal to negative 2x plus 1. This is what I'm going to substitute into the other equation. So I have 2x plus my value for y is equal to 5, negative 2x plus 1. When I go to combine like terms, I put my x's together. 2x's plus negative 2x's, hey, those are a 0 pair. So I get the answer. They get the solution of 1 is equal to 5, which we all know is not true. So 2 things happen. My variables canceled, and my equation, the number sentence I'm left with, is not true. So therefore, no solution. When you lose your variables, then they are the same amounts but opposite signs, I end up with them canceling out. If I'm left with a number sentence that's not true, we're going to call that no solution. All right, now we want to solve the system. Same one, except we're using linear combination this time. We use substitution, we use graphing. Those are our three ways. All right, so I have 2x plus y is equal to 5. And my second number sentence is 2x plus y is equal to 1. So I'm going to go ahead and multiply my one equation by a negative. So we'll go ahead and multiply this equation by a negative 1. So when I rewrite my system, 2x plus y is equal to 5. And I have negative 2x minus y is equal to negative 1. Check it out. I have a 0 pair for my x's. Uh-oh. I also have a 0 pair for my y's. So 0 is equal to negative 4. No, it's not. So again, all of my variables cancel, and I end up with a equation that is not true. 0 is not equal to 4. Therefore, there is no solution to this system. Alright, let's check out the next page. So when we're looking at these outcomes, we can identify a different kind of thing where I have many solutions, and we're not really talking about many solutions here. We're talking about infinite solutions. Alright, take this system and solve it by graphing. I'll take this line first, and I'll say negative 2x plus y is equal to 3. I'm going to add 2x to each side. That's going to give me y is equal to 2x plus 3. So 1, 2, 3, and a slope of 2, rise 2, run 1. If I wanted to, I could fall 2, go back 1. So we'll go ahead and draw that line. Now let's look at our second equation right here. I have negative 4x plus 2y is equal to 6. I'm going to add 4x to each side, because remember I'm solving for y. 2y is equal to 4x plus 6, divide by 2, divide by 2, divide by 2. Y is equal to 2x plus 3. Hey, wait a minute. I have the same y-intercept and the same slope, which means when I go to graph this line, intercept of 3, slope of 2, rise 2, run 1, fall 2, run 1, I end up with coincident lines. Lines that are exactly on top of each other. So we say that this line has infinite solutions, and the lines are coincident. Hey, what a coincidence. We are the same line. So how many XY ordered pairs do we share? All of them. Okay, so that was graphing. And you know, of course, we're going to do substitution and linear combination. So let's try substitution first. Negative 2x plus y is equal to 3. And negative 4x plus 2y is equal to 6. We'll go ahead and solve for y in this equation. Y is equal to 2x plus 3. I added 2x to each side. So we'll go ahead and substitute that in for y in my second equation. Negative 4x plus 2 times my value for y is equal to 6. I'll take the 2x plus 3, and then I'll continue on. Negative 4x plus 4x, remember I have to distribute, plus 6 is equal to 6. Combine like terms, they cancel out. 6 is equal to 6. Guess what? That's a true number sentence. So my variables canceled. And guess what? I was left with a true number sentence. One more. Let's go ahead and solve this using linear combination. If I write my two equations, 2x plus y is equal to 3. That's negative. And negative 4x plus 2y is equal to 6. We'll go ahead and multiply this equation by 2. And that gives me negative 4x minus 2y is equal to positive 6. Here we wind up with negative 4x. We end up with positive 2y, and we end up with 6. 2y This should have been multiplied by a negative 2. That would give me positive 4x, and negative 2y, and negative 6. Go back and double check those signs. When this negative 2 is multiplied by this, I get a positive. When this negative is multiplied by y, I get a negative 2y, and here's my negative 6. My signs didn't look right because I know exactly what's supposed to happen. Here's the 0 pair. Here's the 0 pair. And here's a 0 pair. When I get 0 is equal to 0. So in this story, my variables cancel. And guess what? I was left with a true number sentence, a true equation. Okay, so when we're identifying the number of solutions, we can look at and put into a table some of the things that we need to understand. All right, when there's one solution and I'm graphing, my lines intersect. When there's no solutions and I'm graphing, my lines are parallel. When there's infinitely many solutions and I'm graphing, it graphs to be the same line. All right, let's talk about substitution. When I'm using substitution, I have one xy ordered pair. When I have no solutions, my variables cancel, and I have a false equation or number sentence left behind. If there's infinitely many solutions, my variables cancel, and I'm left with a true number sentence or equation. All right, through linear combination, if I have one solution, I have an XY ordered pair. If I have no solutions through linear combinations, my variables cancel, and I have a false equation or number sentence. Those two things are the same thing. Infinitely many equations, everything cancels. And that's what we saw up here when I ended up with 0 is equal to 0. Alright, so looking at this last part of this page, solve the system and interpret the results. So when we solve the system and interpret the results, we need to let everybody know, hey, what happens? You can suspect some of these are going to be a little weird. Let's go ahead and multiply this by 3. And I get 9x plus 3y is equal to negative 3. When I write my second equation, negative 9x minus 3y is equal to positive 3. Guess what happens? Every single one of these is a 0 pair. Therefore, they're infinite solutions. And we can say that's all real numbers. Alright, let's look here. When I multiply this by 2, I end up with 2x minus 4y is equal to 10. When I write my second equation, negative 2x plus 4y is equal to 2. Uh-oh. Can you see what's going to happen? Cancel. Uh-oh. Cancel. So guess what? I get 0 is equal to 12, which we know is not true. So therefore, no solutions. And sometimes we write that as the empty set. All right. So good job today. Keep up the work. Do your homework.